Let's move on to the subject matter of today, and that is whether physics is math and math is physics. Are they synonyms? Is that what physics is about? Just math equations. We measure, create some standards, and then just put out a value and say, that's physics. I did physics. So what do we call this? You know, here you have a pen, okay? And it falls to the floor, right? There it is. It just falls. We all know what happens with all this. Here it is. You know, one more time. We got to do repeatable for it to be scientific, right? According to mathematicians. Here it is. We let go of it, and it falls to the floor. Yeah, it always falls down. Never falls to the ceiling. Okay. I don't know if you noticed that, but you can try it at home. Very expensive, very dangerous experiment. Do it in the presence of a relativist always. Anyways, if that falls, is that a question of physics, or is that a question of philosophy? And so some people will say that it's a question of philosophy, that it has nothing to do with physics, because physics is only about equations, about measuring, about math, about numbers and variables. That's what physics is about. And so we have first a couple problems. You know, what do we do with this? Where do we put this incident, this physical phenomenon? You know, it always falls to the floor. And here you have another one. You have magnets. One attracts the other, right? You can see that, the two magnets there, and they attract each other. And so these qualitative phenomena that we observe daily, like, you know, falling of a spoon or magnet attracting another, is that philosophy? You know, the cause, the mechanism, how it works, the physical interpretation. We call it physical interpretation and say it's philosophy? And then the third issue is, okay, if it's philosophy, why are the so-called mathematical physicists answering these types of questions? Why do we ask them these questions if they're on record saying that they don't do this kind of work? They do math, they do equations. Why are we asking them these questions? You take people like Sean Carroll, and you have people like Sabine Hassenfelder and Brian Greene, all these people, Neil Tyson, and all these people are answering qualitative type of questions. People are asking them these questions. These people are trying to answer these questions. They never give you an answer. And the ultimate answer is, oh, by the way, that's just philosophy. That's not part of physics. That's not what we do. What we do is equations. And so we have all these levels of problems. First, is physics the same thing as math? Are they just equivalent? That's all they do, just equations. If that's the case, you know, what do we do with all these other physical phenomena like gravity and magnetism, light, the workings of the atom? Where do we put those? Philosophy? And if it's philosophy, why are the so-called mathematical physicists trying to answer these questions? Okay, so we have all these levels of problems, right? And so let's find out what people have to say about it. Here we have some comments that people made this week about my last presentation, my last lecture, and I think they speak for themselves here. It says, mathematical physics have a very specific meaning. It covers all the problems that can be expressed as Cauchy problem, and nothing else. Heat equation, example heat equation, it works. Yeah, the fact that it works does not mean it's part of physics. If it works has to do with technology, and technology is not science. Okay, technology is developing gadgets by trial and error. Science is explanations, rational explanations. So the fact that it works has nothing to do with science. Okay, and here we have another fellow. He says, we observed that a spoon falls, and we then check it to see how the data we collect on its falling correlates with what? Theories of what is making it fall. Okay, he's talking about the theories, the explanation, the causes of what is making it fall. These are his words, right? I didn't put that in there. He said that. And says, we check Newton's inverse square law, and we find very good agreement. Yeah, that's a description so far. You're not telling me anything about a theory of what's making it fall. In fact, Newton admitted he had no idea what's making it fall. This means Newton's theory passed a test. No, he didn't pass any test. The test is what is making it fall. There, we're using your own language. If we do lots of tests and Newton's theory keeps predicting accurately, we say the theory is likely correct. So far, he hasn't had a theory. He hasn't proposed a theory. The fact that you can predict, which is just a description, does not tell you anything about what is making it fall. So we find that Newton's theory doesn't exactly predict the measured perihelion of Mercury. Einstein explains all the things that Newton explained. Talks about explanation. See, he's using the word Einstein explains, Newton explained, right? Perfectly, and it also explains, once again, the perihelion of Mercury. It has also passed every other test that's been thrown at it for the last 110 years. That's how we know. It is probably a true explanation. Again, explanation. So far, we have no explanation. He hasn't talked about any explanation. The explanation that Einstein provided was that we have warped number lines. And the explanation that Newton provided, which he said he had really no explanation, but he did everything with particles. So you could not explain with particles how the moon attracts the earth, how the sun attracts the earth, and all the planets attract each other. You cannot explain that with particles. And that's why he said he had no, hypothesis. And then he says, that's how we know it probably is true, a true explanation. And again, this person doesn't have an idea what he's talking about. He doesn't know what an explanation is, and that's going to be the subject matter later on today. But explanation is that what he said at the beginning. Theories of what is making it fall. That's an explanation, okay? And then so he just talks about math and the fact that experimentation gives us some equations, tells us how something is moving, but there is no explanation as to what's causing it to move like it moves. That's an explanation. That's what science is about. Not the fact that you measure something and say, oh, the pencil fell to the floor at 9.8 meters per second square. That's not science. That's like measuring a table and says, oh, the table is 1 meter and 1 micrometer long. Right. Is that science because you measured the table more accurately than the other guy who said it was 1 meter? You measured it more accurately. You got a better caliper or whatever, and you say, I measured it much better than the other guy. So you get a Nobel for that, for measuring it better. Okay, here's another fellow, and he says the following. He says, you talk about how mathematics can only describe, as if that somehow invalidates its usefulness in physics. They talk about use. They're talking about something else. They're talking about, technology. They're not talking about science. Science has nothing to do with usefulness. Science is not useful. Science is only there to understand how this universe works, okay? There is no usefulness. And what he's talking about, again, equations, okay? That's why he says that it's useful in physics, because he brings equations into physics. Yeah, we don't use equations in physics. Physics is qualitatively only. You have to explain what causes this pencil to fall to the floor. That's what rational people want to understand. Mathematicians, who are irrational people, they want to understand how much, how fast, how much it weighed, how much time it took. They're into something else. They're not into physics. I'd be interested to see you attempt to describe, uses the word describe, right? In detail, even the most basic, physical interactions in nature without mathematics. Yeah, mathematics is about description. We don't care about that. We do explanation, not descriptions in science, in physics specifically. Let alone make predictions. We don't do predictions. Predictions is astrology. We don't do predictions in science. Palm reading, foretelling the future, you're in the wrong business. Whether it's words in mathematical language, you're still using the same principles of logic and reason. Okay? But I like what he says next. You'd think someone that objects so strongly to the use of constructs like fields in physics would value a formalized language for logic and reason over imprecise everyday language. Okay, let me show you the precise language that mathematicians use. Here it is, okay? See if you can find any precise language here. Here it is. Let's put this one here. Energy. What is it? It's the quantitative property. That's what it is. And then they tell you that they're going to transfer this property. How do you transfer a property? I mean, if it's just a characteristic of something, how do you transfer a characteristic, which is what these people are saying when they give you their physical interpretations. And then you have mass. And what do you find in the Wikipedia? There's at least 7 different aspects of math. There's 7 different notions of mass. Okay, so they don't have any definitions. In fact, look at what Feynman says about energy. It is important to realize that in physics today we have no knowledge of what energy is. And again, Feynman was not smart enough to realize that energy is not a what. It's not a noun. Okay, energy is what a quantitative property. And yeah, that way you cannot say that you know what energy is because it's not a what. It's not a thing. Okay. Then you have force. What is it? Force and influence. Great. What is time? A continued sequence of existence. So you persist and you have time, whatever that means, right? Because you can see how they define the word time in terms of past, present, and future. You look at past, present, and future, and guess what? You find out that it's defined in terms of time. Then you get the word field, a physical quantity. And they shake this. They say the physical quantity is vibrating. And when it vibrates, it turns into a particle. So, if a field is a physical quantity, you cannot use it as a physical object in science, okay? So, we have all these people who define these terms, the mathematicians, and they never realized that what they were defining as concepts, then they use these concepts as physical objects, and so they have all completely imprecise language. That's what they ended up with. And so this person talks about logical and precise language when mathematics does not have a single word related to physics, which they claim are related to physics. Not one of those is defined properly. We don't have scientific definitions from anyone in mathematical physics. Okay, so not only are they introducing words into physics, but none of their words are defined to begin with. So we have undefined words introduced into physics and treated as physical objects. They're going to move the mass, they're going to transfer the energy, they're going to vibrate the field or shake the field or talk about the excitation of the field, and they say that's a particle. So what is a field? A bunch of numbers, and they say that a bunch of numbers vibrating, that creates a particle. All completely nonsense. None of those terms have been scientifically defined. Okay, so how do we do it in science, in real physics? Well, the main thing is that you have to define what I call the foundations of physics. You have to lay the foundations of physics. And the first item there is the golden principle of physics. You have to lay down the golden principle of physics that you can't do physics without an object. What would be going on in the universe if you wiped all objects out of existence? If there's nothing there, what would be happening? What would you be measuring? What would you be testing? What would you be observing? What experiment can you run? You can't do anything if there's nothing there. So hopefully the first thing you need in physics is objects. You need objects, okay? And so the foundations of physics involves the definition of all these words. You need to have these words if you're going to give a physical interpretation, which is what physics is really all about. That's what we're going to argue today. And you need to define the word object, that which has shape, not that which you can see or touch. So whenever people raise issues of how come you can't touch this, how come you can't see this, well, now you're talking about nonsense, because the definition is not see, touch. The definition is shape, okay? So something can have shape doesn't mean you can see or touch it. We can't see the air even though it's made out of atoms. You can't see the table of the ET that's on the other side of the universe, okay? Does that mean the table's not an object, not a thing? Yeah, it's a thing because it has shape, not because you can see or touch it, okay? And shape, all objects in the universe had better have shape, okay? Because if there's an object that doesn't have shape, please show it to me. Make a drawing of it, okay? Illustrate it. Space, that which doesn't have shape. So if a thing is that which has shape, nothing is that which doesn't have shape. Antonyms, you can use them scientifically now because one is the opposite of the other. Distance, separation between two objects. Okay, you need the word object to define distance. You need two of them. Separation, that's distance. What is location? The set of distances from one object to all the others in the universe. Okay, so we have, that's the location of that object with respect to all other atoms in the universe. So if you take any atom, I don't care which atom you want to pick in the universe, the location of that is with respect to all other atoms in the universe. And it's a set of distances. So now we have a definition for location. You can also use the word location for any subsystem. You can take any object. You can say, what is the location of the pen in the room? Okay, you can do that. And you can just say, well, okay, there's distance with respect to all these atoms in the room. You can also take big chunks like, say, the wall, the roof, or whatever. You can say there's distance between the roof and the pen. There's distance between the wall and the pen. That's the location of the pen inside the room. So you can use it for subsystems as well. Exist. What is exist? We just covered that. Physical presence. Object that has location. Only then can an object be said to exist. It has to be an object. It cannot be a concept. You cannot say that intelligence exists, especially in Cambridge and Harvard. And you cannot say that love exists. Love does not exist in science. Okay? It exists in poetry only. Motion, two or more locations of an object, and concept, a word that invokes or embodies two objects. And a rule of thumb there, the quick way of telling whether it's an object or a concept is, can you draw it? Does the concept have shape? And hopefully there's no concept that has shape. Love, what are you going to put, a heart? Yeah, if you put a heart, the heart is an object, but that's a pictorial representation that we gotten used to as a representation of love, of the concept known as love. But heart and love are two different things. Heart is a thing, love is a concept. So, you need to separate all these words. You need to define these terms. And once you define these words, we're done. Now we can use them rationally and give physical interpretations, which is what physics is about. One fellow says, math is defined as the science of measure and number. A number is a name given to a measure that describes a ratio of magnitudes, according to John Gabriel. Okay? So I looked up John Gabriel, find out what he had to say about number. He says the following, says, after Euclid and before me, no one understood what is a number. So he says he's the guy who essentially rediscovered Euclid's definition of number. Okay? And he says a unit, this comes from Euclid, a unit is that according to which each existing thing is said to be one. Okay? Unit is one. Great. Okay. One is unit. Unit is one. Sounds like a circular definition. Okay. Number is just a multitude of units. Okay. And, no, I sent the letter to Mr. Gabriel and he hasn't answered. But this is what I say. I say he did not discover what a number is. Okay. And so let's go through this real quick so we understand what math is, what the foundations of math are, which is numbers, right? And you have number is not the same thing as numeral. Okay, there are two different things. Numeral is the symbol. Okay, the symbol 5, right? That's a numeral. And what does it represent? Well, it represents the number of times you waved your hand back and forth, up and down to count something. So, you count units. In that sense, Euclid was right. But the emphasis is not on units. The emphasis is on counting. Number is a verb. It's not a noun. Number means to count. That's what it means. Okay. And so these people are focused on units and saying, well, we have many units. Yeah, no. Number is the verb to count. You have to be counting. Number is a dynamic concept in great measure because you are comparing 5 against 4 against 3 against 2. 2 is not the same thing as 3, 4, or 5. Why? Because what you're doing is moving that finger up and down, and you're giving names to each one of those representations. So if you're moving it twice, you call that a 2, and you're moving it 3 times, you call it a 3, and so on down the line. So you give a numeral, a symbol, to represent the number of times you moved your finger. But what does that numeral represent? Counting. How many times you counted something. Okay, and fellow that we need to bring this up as well, brings up the issue of 0. Says 0 is not a number. Counting starts at 1. Measurement starts at 0. Get 0 off the number line. And he's totally right. Totally right. 0 is not a number. You cannot have either 0 or negative numbers. Again, so it says it does not exist as a value. It's a balance between two positive magnitudes. Negative numbers don't exist. You can't have negative magnitude. And yes, again, negative numbers were invented for accounting purposes. You know, I owe you 3 apples, so I have a negative 5 apples. Or 5 apples or 10 apples, you know, because I owe you. And so it's just an accounting issue. And so they put a negative sign there saying, okay, if you owe me, then you have negative. And so they started working with negative numbers. And yeah, you cannot have negative numbers because that just means I owe you. That's an accounting practice. It has nothing to do with the real number system, which is, you know, 1, 2, 3, 4, 5 to whatever number you want to count to until you get tired. Okay. And so, yeah, we have a problem because they introduced negative numbers, and then they introduced, again, all these values. In fact, one of them is the irrational number, which is square root of -1. And that's a long story. So, you know, you can't have negative, you can't have a negative square root of number 1 because you would get a -1 and a +1. And so you would not get either or. You would not get two plus ones or 2 negative ones. Either one of those would give you would never give you a square root of -1 if you undo that. But the point is, they invented all these irrational numbers. They invented negative numbers. They invented zero. They invented a bunch of stuff that has nothing to do with the real world. Okay, there are no such thing as 0 apples. Because 0 apples is the same thing as 0 trees, 0 rocks, and 0 houses. They're all 0. Okay? I can't tell the difference between 0 houses and 0 apples. I can tell the difference between 1 house and 1 apple, but not between 0 houses and 0 apples. Okay? Anyways, okay, so let's get going here. Where did all this nonsense start? Well, as always, all the nonsense started with the Greeks. And instead of brushing all that aside and starting all over, they just continued with that, just modifying it over the years. And here we have good old Aristotle, and he said he's the guy who defined physics, the word physics, okay? So in a way, we have to respect that because he invented the word physics, which just means writings on nature. That's what he apparently labeled his book. But from there, they went and said, well, what he did was natural philosophy, and what we do is science, which is physics, and it's totally different than what he did. Why? Because it includes experiments, which Aristotle did not do, and we have more sophisticated math. We measured things, and he didn't do a lot of that stuff. Okay, so what did Aristotle think physics was about? Well, if you go to his book, he's got, it's eight books into one, right? The physics book contains 8 books, each one with chapters and so on. And what Aristotle talked about was these things. He talked about matter, what a thing is made of, object, right? Things, right? Place, position, he called it, or location, the site occupied by an object, essentially, right? Space, he think there was no such thing as a total void, because as soon as a void becomes available, something occupies it, so everything is always constantly filled. Everything in the universe just moves around by pushing or, you know, displacing whatever was in that space, right? So if I move my hand, what I'm displacing is all the air that occupied that space. And so there is no real vacuum. What I'm doing is just pushing stuff that was in the space that my hand occupies now. That's essentially the notion, okay? And motion, he said it's potentiality that becomes actuality. Something has the potential to move. When it does move, when it carries out that, you know, becomes actual, what was potential becomes now actual, he called that motion. So, yeah, that's a funny way of looking at motion. We call it 2 or more locations of an object, okay? But he says it's potentiality that becomes actuality. And time is just a quantification of motion. Quantity of motion. That's what time was for Aristotle. And what Ari did was he established the difference between a mathematician and a physicist because of this, right? And so this is what he's had to say. He says, the next point to consider is how the mathematician differs from the physicist. Okay, so he's going to talk about that these two guys are different people. Okay, the physicist is not a mathematician or vice versa. Obviously, physical body contains surfaces and volumes. What is he talking about? Things, okay? And he says volumes, lines, and points. And these are the subject matter of mathematics, okay? So he's saying that the thing belongs to physics, but the volumes, the lines, and points that the mathematician is going to use, that belongs exclusively to mathematics, okay? So we have a separation between the objects, the things, how something moves, what location it has, those belong to physics. And what belongs to mathematics are the analysis, quantitative, the relations between, lines and points and etc. And he says it seems absurd that the physicist should be supposed to know the nature of sun or moon, but not to know any of their essential attributes, particularly as the writers on physics obviously do discuss their shape, right? Also, and whether the earth and the world are spherical or not. So what is he saying? That the things, essentially, any discussion of things, location, existence, thing that has location, all that belongs to physics. And what belongs to math are the analysis, the quantitative analysis, the relations. You establish standards and you compare things. That belongs to mathematics. So he established that difference. And that difference was really switched around. They converted all that into, the relations, they converted that into physics. And physics they relegated to philosophy, or what they call metaphysics. Here's Metaphysics, another book written by Aristotle, right? And he called it first philosophy, or the study of being qua being, okay? Being for their own being's sake. And he was talking about existence, knowledge, wisdom. He had a hodgepodge of notions that he analyzed in metaphysics. And so people say, well, see, all this stuff, that belongs to philosophy. They essentially equated metaphysics with philosophy. And the problem there is, especially that first word there, existence, that belongs exclusively to physics. Physics is the science of existence. Physics only deals with what exists, okay? And so for them to put the word existence with metaphysics, meaning with philosophy, that's where we run into trouble, okay? Philosophy does not deal with existence. Philosophy is something else. They never defined it, so we have to define it for them. Philosophy is explanations of behavior, okay? Philosophy talks about purposes and reasons why someone did something. That's philosophy. It has nothing to do with existence. Existence belongs exclusively to physics. And the reason all these people run around in circles talking about whether God exists or not is because they put existence into philosophy. And they think they're philosophizing. They're not. When anyone touching the word exist, whether they know it or not, has crossed the line over into physics. Okay? Only physics deals with existence, what exists out there. Okay, and just to mention this, we have this is a fellow by the name of Pythagoras. He came way before Aristotle, and he had a theory of numbers. He's saying that all objects are numbers. So he's saying an object is a number. A tree is a number, okay? And the only thing I'm going to say there is no such thing as theory. In other words, explanation in mathematics. Okay, so when he has a theory of numbers, that's a total contradiction. Theory is an explanations. Numbers do not explain. Numbers only describe, okay? And that's all that math can do. So we, again, start on the wrong foot because all these people confuse the word description with the word explanation. They think they're synonyms, okay? And no, they're not. Okay, so let's just get some of that straightened out. Okay, so let's see some of these definitions today. What came out of all this work by the great scientists of Greece, and in fact, all those that came after. Here it is. Well, we have this from the Wikipedia, okay? The peer-reviewed encyclopedia, right? Because you can't put anything in there unless it's peer-reviewed by people who control the article. So it is a peer-reviewed encyclopedia. People sometimes dismiss, oh, you found that in Wikipedia. Well, Wikipedia. Anybody can write in there. No, not anybody. Because as soon as you write something, you'll have 100 people who will say, we're not going to let you put this in our article. So you have people controlling each article. and especially in the mathematics, all these mathematical concepts, they're peer reviewed. Okay, anything that is not peer reviewed does not enter the Wikipedia. In fact, no one has ever put the rope model in there, and someone tried to do that, and it was rejected because they said, well, it was peer reviewed because, my article has been peer reviewed by the IEEE, right? And they said, well, it's got to be there's got to be at least 2 articles. There's only 1 article, so they just said with that, they rejected on that basis. So yeah, Wikipedia is peer reviewed. They will not allow the rope model to enter there, at least for the time being, right? And so what is physics? Well, this is, according to Wikipedia, the natural science of what? Matter. Okay, so far, pretty close, because matter is objects that exist. So yeah, physics does deal with objects that exist. But then it continues as involving the study of matter. No, in physics, in science, we do not study. Okay, anybody can study and not know absolutely anything. You can study all week and get a 0 on the test on Friday. That doesn't mean that study turned into science, into knowledge, or whatever you want to call it, understanding. Okay, and then its motion and behavior, what? Through space and time. Now, you cannot move through space and time because space and time are not physical objects. You can, you're not moving through an ocean. You're not moving through air. You're not moving through a volume there that contains something. Okay, space is nothing. Time is even worse than nothing. There's no such thing as time. Time is a relation. So you can't say that you move through space and time. So physics doesn't study motion through space and time. And the related entities of energy and force. No, energy and force are not entities. Entities is a synonym of objects. Thing, entity, object, anything, body, substance, they're all synonyms in physics. There's no difference between them. Okay? And so energy doesn't, or force, they don't fit the mold. They don't have shape. Energy is not a physical object. Energy is a concept, a mathematical concept. It's an undefined mathematical concept. No one has ever defined the word energy in a way that they can use it rationally. So the word energy does not belong in science. It belongs in religion, completely in religion, in the religion of mathematical physics. And the same with force. Force, they have 4 forces, which I call the 4 horses, right, of the apocalypse. These 4 forces. And I'm not sure what they could have invented because you only have push and pull. That's the only 2 forces, only forms of contact that we can imagine. Either you pull or you push. And there's no other way that you can have physical contact. And what they're saying is they discovered 4 forces. And what are they? Well, you have the gravity, which is pull, and you have the gluons, which is also a force of pull. So I don't know how the gluon differs from the force of graviton when they both pull. And then you have the force of the photon, the electromagnetic force, which pushes, and you have the weak force, and that's also a push force. So I don't know what's different between the weak force and the electromagnetic force if both of them are push forces. There's only 2 forces anyone can imagine, push and pull. But they discovered maybe and perhaps. Great. Okay. Anyways, mathematics, a field of study. Now again, if you can study all you want mathematics, not understand anything, and that doesn't make you a mathematician. Okay, and what organizes methods and what theories and theorems? No, there are no theories in mathematics because theory is an explanation. It is not a description, and math can only describe. So you cannot say there are theories in mathematics. There are no theories in mathematics. And what is a theorem? Well, it's a statement that has been proven. And proven to whom? To the Pope? To the Dalai Lama? Who did you prove it to? I mean, all these so-called theorems are just, they're tautologies. What's on one side of the equal sign is the same thing as on the other side of the equal sign. So there's no proof, what they call proof. Proof means that you are going to convince someone of something. And you can try to convince a born-again Christian that there's no God, and he's going to continue believing that there is a God. So proof is a matter of opinion. It's called religion, opinion, whatever, just your personal opinion of something, that your personal belief. That's all that proof is. That's all that knowledge is. Knowledge is the same thing as belief. And so when you look up the word theory, it says a rational type of abstract thinking about a phenomenon or the results of such thinking. So I'm thinking about the cake and ice cream I ate yesterday. That was a phenomenon. And it was very good. So is that a theory, what I just said? Because I liked the cake and the ice cream I ate yesterday? So no, this is not the definition of theory. Theory is a synonym of explanation. We need to define the word explanation. We'll know what a theory is, which is just a synonym. And in fact, they say it later on. They say in mathematics, the term theory, right? Listen to this. The term theory is used differently than it's used in science. Since what? Mathematics contains no explanations. It says it right there, same article. So we have a problem because they say theory is just an abstract thinking. And then they say, well, mathematics, they use the word theory a little differently because in mathematics, theory is not an explanation. Meaning that's what theory is, an explanation. And so the mathematicians call their descriptions theories. They call their descriptions explanations, and they have this notion that explanation is a bunch of descriptions. That's where the problem is. No, an explanation is not a bunch of descriptions. Explanation differs. It explains that because it deals with causes, something that a description does not. Okay, that's primarily the difference between them. And we'll get to that in a second here. Here it is. This is the Wikipedia again saying that that math has something to do with predictions, or that physics has something to do with predictions. And it says mathematics is used in most sciences for modeling phenomena, okay, which then allows predictions to be made from experimental laws. So I don't know what experimental laws are. We don't do any experiments in science, and especially in physics, and they talk about predictions. So they say, well, we got this equation, so we already measured this 1,000,000 times. We can now predict because we measured it, we've got the numbers, we've got the units that we made for it. We know what's going to happen if we repeat the experiment. Okay, that's what they're talking about. And what does that have to do with science? Science is about understanding, not about being able to describe something and say, this is going to happen because we measured it 1,000,000 times. You weigh the elephant, it weighs 5 tons. Okay, so we put him on the scale. What's he going to weigh? Well, he's going to weigh 5 tons. And if he eats, a bunch of grass or whatever he eats, we put him on there and we weigh the grass before he eats, and we say, well, this weighs, 50 more pounds. Now the elephant's going to weigh 5 tons plus 50 pounds. Great. So you can predict. That's science. They call that science. No, prediction is just a description. And it's not equal to science, because what? Science is rational explanations, not descriptions. Prediction without more is just a description. You can predict that tomorrow there's going to be an eclipse of the sun, right? The moon's going to pass between the earth and the sun. And so far, if you just say it's going to happen, you haven't explained anything. You haven't explained why. The moment you explain why, you're talking about the past. Why is always have to do with the past. Okay? Science is only about the past. You are explaining a consummated event. What are you explaining with this prediction that happens in the future? You're explaining what you already measured in the past. You already had an experience with eclipses. You finally figured out why that happened, what the cause of it is, the moon going between the earth and the sun, and you know that it's going to happen once again. So you predict and say at such and such hour, this is going to happen again. Why? Because we know that by this time, the moon has to go right between the earth and the sun. So now you have an explanation. Why you have an explanation for this prediction? Because you're basing it on your experience. Experience is always past tense, never future tense. Okay? Physics is rational explanations of what? Causes and mechanisms. Only then you have an explanation. Okay? Okay, so here is the science definition of Wikipedia. See if they're even hit that one on the nose. Science, a systematic discipline that builds and organizes what? Knowledge. I thought knowledge was belief, justified true belief. In fact, that's what good old Plato defined it as, justified true belief. That's the translation, essentially, of Plato's book, right? And when you look up now, it says, despite agreements about the general characteristics of knowledge, its exact definition is disputed. So we don't have a definition of knowledge because they have opinions about what knowledge is. They have theories of knowledge. They never define the word knowledge. They don't have a definition of the word knowledge. And when you look it up, it all comes down to belief. Knowledge means just stronger belief. That's all it means. When you know something, when you know your wife cheated on you, you have a very strong belief. That's all you have. Maybe you're wrong, but that's your knowledge, right? And then in the form of what? Testable hypothesis. I love that one. Testable hypothesis. We talked about predictions, so I'm not going to cover that again, but testable hypothesis. What is a hypothesis? A proposed explanation for a phenomenon. I thought that science, according to the establishment, was not about explanations. And now they're talking about testable hypothesis, that you're going to test an explanation. You're going to try to verify the explanation to see if it's correct. And just in case, we have, this gentleman, he's a professor in Pennsylvania, and he says the following. He says, science doesn't explain. Science describes. So we have a contradiction. We have all these runarounds. They're saying science goes out there and does testable hypothesis. What is a hypothesis? A tentative explanation. And this fellow, who is a professor of physics, he says, oh, by the way, science doesn't explain. They don't do hypothesis. What they do is describe, which is not a hypothesis. Okay, he goes, what sort of answers can science give? If you want some mystical, ultimate, or absolute answer, you won't get it from science. Philosophers of science point out that science doesn't answer why questions. Science only answers what? How questions, meaning mathematics. That's what they call science. Science doesn't explain, science describes. Science postulates models to describe how some part of nature behaves, then tests and refines that model till it works as well as we can measure. Meaning they're going to do technology and they're going to talk about this as being science. Okay, so they're equating essentially science with technology. They're saying that science is not about explanations. Science is about descriptions, mathematical descriptions. So why does everybody go to a scientist? Why does everybody go to a physicist, so-called physicist, mathematical physicist? Why do they go to Sean Carroll? Why do they go to Neil Tyson? Why do they go to Brian Greene? Why do they go to all these people asking them why questions, explanations, if they say it's not part of their, job description? They don't do why questions. They don't do explanation. And in fact, they try to do that. They give you the most irrational answer they can give you. When you question that, they say, by the way, that's philosophy. That's semantics. We don't do that. So why do we ask them? Why are we asking these people questions that they cannot answer, that is not part of their job description, part of their line of work? If they're into math, stay within math. Don't come into physics, which is what we're talking about. If this pen falls, and we want to answer why, what caused this to fall, then hopefully we ask someone, a physicist, not a philosopher. And they say, well, this is philosophy. So is this philosophy? Is the falling of a pen, is the magnetism between two magnets there, is that philosophy? That's not part of physics? And if it is part of physics, these people can't answer the question. They tell, well, that's not part of physics anyways. It's philosophy. So we keep going around in circles and circles, and nobody ever addresses these issues. I mean, if they do testable hypotheses, and hypotheses are tentative explanations, and then this professor and just about everyone else says that, they don't do explanation, they do just description. Why are we asking these people these questions? Why are they brought in talk shows and say, tell us about physics? And people ask them questions, they say, it's, because it branches out in several universes, and you could be in this universe and another universe over there. And you say, well, that's irrational. Yeah, it's all philosophy. It's So we keep going around and around in circles. Okay, so what is a description? What is an explanation for the purposes of science and purposes of physics? Here we have it. Description, a listing of properties of a physical object. That's all a description is. Okay, you have some synonyms. In science, we use adjective to describe objects. Okay, so description is just full of adjectives. We use the word narration, narrative, right? Typically a chronological listing of events. Okay. That's the how of mathematics, and what they do is quantify it, right? It's a story, it's an outline, chronicle, that's what it is. Okay? In science, we use adverbs to qualify or characterize motion. That's what mathematics is, just an exclusive language of quantitative adverbs. That's all that mathematics does, that's all an equation is, that's all that all these numbers and variables mean. It's just quantitative adverbs, how something moves, okay? Math only describes and therefore is not a scientific language, because what science is? Rational explanations, not descriptions. A narrative is an uncolored, unopinionated story, objective reporting. And what is an explanation? Well, it's something totally different. It's the causes. Okay, the causes for the purposes of physics, reasons in the case of philosophy, right? Underlying a phenomenon, the prosecutor's version of how or why a consummated event happened. And the how has to be in terms of what caused it. That's what the how means there, okay? So explanation is the why, the theory. That's what an explanation is. It's got to do with causes. You have to theorize what caused something to happen, okay? And so you can see they're different than narration, which is what mathematicians do, which is just a chronological listing of events, typically chronological. And all they're doing is quantifying it with adverbs and saying this is how something moved. This is how it happened, not why it happened. And so it's not strange what I showed you the other day that good old Neil Tyson, he wasn't able to explain gravity. And here it is again to his words. He more or less puts it all in the right perspective of what we talked about today. Here it is. Let me show you. Here it goes.
Science can describe how gravity works, but can they describe why it works? So this is the how-why duality here. In science, if we can describe how something works and predict its future behavior, we claim to understand it and we move on. There's a point where it's not especially productive to continue to think about the world that way. When you understand the how enough, are tantamount to having answered the why question. I can describe what gravity is doing. I even have a mechanism for it. Gravity really is the curvature of space and time. Movement of matter on that fabric of space and time we call gravity. Why does matter and energy curve the fabric of space and time? And I don't have an answer for that. Why does matter and energy curve space and time? Okay, that's a frontier. We're still working on that.
So why do we ask people like Neil Tyson, which has no answers to why questions, to explanations, and he believes that an explanation is a bunch of descriptions, and like he says, as long as they understand the description, they can measure and they can create some gadget, technology, they move on. And so they have this totally misconceived universe of how it works. They ended up with black holes, dark matter, all these spirits out there. They're conveniently invisible, conveniently heavy, with which they explain everything. And the question is whether there are such invisible, spirits out there, such as black holes and dark matter, dark energy, singularities, and whether Big Bang ever happened. So they have all these virtual particles, which are particles which they put in by hand, into their equation. They need that because otherwise the equation won't work. And so they say, well, it's a virtual particle. It just comes in and out so fast we can't measure it. Just, the angel came, did his job, and left in a split second. We weren't able to measure him. And so they have all these things today are not things. They're invisible spirits that enter the world of math. They do a lot of math. They do a lot of research on them, and there's nothing to show for them. They cannot show you dark matter. They cannot show you dark energy. They cannot show you black holes because they are invisible. And then they illustrate it. They illustrate a black hole and they say, okay, I understand what that is. That hole there with all this lightning around it, this halo around it. No, that's not a black hole. Black hole is 0D, 0 dimensional. That's what a singularity is. So, and then even if we concede all their assumption, how does it affect a star far away? And again, that's done through witchcraft. It's called action at a distance, through mass, through gravity, whatever. And they say, well, it's through space-time, all these, gravitational waves. What's a gravitational wave? It's the undulation of number lines, because what they're talking about is math, not physics. They're talking about the fact that they have these number lines, and they say, well, over here, the number line has such and such value, and over here it has another value. So they're talking about bending number lines. They call that physics. And, when you question that, they say, well, that's philosophy. They're only looking at numbers. Okay, so I'd like to end it with what I posted as the icon there for this, the Mary Poppins syndrome. That's what we have in math. You have Mr. Banks, the banker. He says, would you be so kind to explain all this? He asks that question to Mary Poppins. She says, let me make one thing absolutely clear. He says, yes, I never explain anything. That's the mathematician answer. Okay, they never explain anything. Okay, so math cannot explain, and here you have all the things that they cannot explain, everywhere from light, gravity, electricity, all the way to virtual particles and the twin paradigm. They cannot explain. They just describe, say, it is so. We measured it, and it is so. That's their interpretation. It doesn't mean that they can explain what they just said. Okay? And this is the problem that we have today. These people are at a crisis, and I'll be talking about that in the coming weeks. Okay? Mathematical physics is at a crisis. They're at a crisis because they're inventing ever more concepts on top of concepts on top of concepts. Mathematical concepts, quantitative concepts. And they just give names to these new concepts. They're developing equations that are totally unnecessary to understand the universe. The equations on black holes related to holography, and they've got all kinds of nonsense out there. And the question is, what do we need all that mathematics for? I just need to find out what causes this pen to fall to the floor. They cannot answer the simple question. And so they're developing unnecessary mathematics. They're bringing it into physics, calling it physics. And the questions that people ask are qualitative questions. They give you an irrational answer when you put them against the ropes and question them about it and say, that's philosophy anyways, that's not what we do. So why did we ask them those questions? And it goes on and on and on in circles.